Injection molding sounds simple, right? Plastic pellets go in, the material gets heated, plasticized, and injected into a mold. Then, boom, a molded part comes out. With a multi-cavity mold, you can crank out dozens or even hundreds of parts at once. That's why it's the king of mass production. But what's really happening inside the machine? At FirstMold, we handle this process every day. So let me show you exactly how it works.
It wasn't always this refined. Early machines were just giant syringes using a plunger to push molten material into the mold. The problem? Plastic is a terrible thermal conductor, so relying on external heat made a uniform melt nearly impossible.
Everything changed in 1946 with James Watson Hendry's reciprocating screw. This was the industry's turning point. The screw's design transitions from deep to shallow flights, which compresses, shears, and mixes the plastic pellets as they move forward. Calmed in with external heater bands, this ensures a perfectly homogeneous and stable melt. Once the screw accumulates enough molten material, it retreats under back pressure to store the shock. During the injection phase, the screw stops rotating and acts like a high-precision piston. A check valve closes to prevent any backflow, and the material is forced through the nozzle, into the runners, and finally into the cavity.
Now, here's the tricky part. Speed control is everything. If the injection is too fast, you risk trapped air, burn marks, or surface defects. Go too slow, and you're looking at short shots where the cavity just doesn't fill. And designers, they have to master the art of venting. These vents are usually only a few dozen microns deep, but they're the only way for air to escape. If that's off, you get gas traps and incomplete parts. That is exactly why at FirstMold, we run digital flow simulations on every project to eliminate these risks before a single piece of steel is cut. After the melt enters the cavity, the part is still not finished. As the plastic cools and transitions into a solid, it inevitably shrinks. To counter this, we apply packing pressure to force additional material into the cavity, compensating for that volume loss. Simultaneously, integrated cooling channels pull heat away until the part is rigid. Finally, the mold opens, and ejector pins release the finished product. This is where draft angles are vital. Without them, the friction against the sidewalls would cause surface damage, or worse, cause the part to seize in the mold.
Ultimately, injection molding is a game of managing hundreds of variables. Choosing the right partner is the difference between success and failure. With over a decade of experience supporting Fortune 500 companies, FirstMold is here to ensure your project stays on track. Ready to get started? Get in touch via the links below, and let's bring your project to life.